Hey YouTube, welcome to Higher Math Solutions. In this video tutorial, we're going to do derivatives using product and quotient rule. So we're going to start with the product rule first. If you want to find derivatives at a product type function, you need to follow the rule. And the rule is if you're taking the derivative of a function times another function, you're going to take the derivative of the first function first times the second plus the derivative of the second function times the first function. And that is the product rule. You don't always have to use the product rule, and it's always good to practice enough where you know when to use it versus when not to use it. So here are a couple examples of when you do not have to use the product rule. If I have a function that looks like this, you could use the product rule if you wanted to, but it's nice to avoid it when you can. If I were to simply just multiply through the parentheses, then this function is not a product anymore, and I can just do simple power rules. Another example is if I have a function that looks like this. This can be rewritten as a product as x plus 1 times x plus 1, but I would still try to avoid using the product rule when you can by foiling it out first. So if you were to FOIL this function out, then you would again just be left with simple power and constant rules, and you wouldn't have to use the product rule for there. But sometimes you can't avoid using the product rule. For example, if I were to use a function, a polynomial for my first function, but if I were to use a trig function for my second function. In this case, you cannot distribute or FOIL out to get rid of your product, and so you would have to use the product rule on this type of function. So you need to decide which is your first function and which is your second. It's easy to realize that because of the multiplication. This would be my first function, and this would be my second function. So to find the derivative, f prime of x, I would do the derivative of the first function first using a power rule. The derivative of x squared is 2x. And then what I would do is I would just rewrite the second function. You don't do anything to it except for rewrite it. Then you will have a plus sign, and I'm just going to rewrite the first function, not do anything to it, and then take the derivative of the second function. And you need to know your rules. The derivative of cosine of x is a negative sine of x. I can rearrange the negative here to make it look a little bit better. So I'm just going to move this negative in the front where the positive should go. And that's pretty simplified, but you can still go ahead and factor out an x if you want to. So if I factor out an x in each term, then this could be your final results. And then that represents the slope of this function right here. Let's do another example. So let's go ahead and do 4x to the fourth times tangent of x. Again, you see one function times another function. There's no way to avoid using the product rule, so we're just going to follow the rule itself. This is my first function, and this is my second. So to take the derivative of the first function, I am again going to use the power rule, and this 4 right here just gets carried along. So what happens, you do 4 times 4, and then subtract 1. And when you do the second function, all you do is rewrite it. And now you're ready for the second piece, so I put a plus sign. I just rewrite the first function, do not do anything to it, and then you take the derivative of the second function. And again, you just need to know your rule. The derivative of tangent is secant squared of x. there's not really a whole lot of simplifying you can do. You can factor out a 4x to the third power, and so that's what I'll do next. I will take out a 4x to the third, and in this case I'm left with a 4 tangent of x, and here I'm left with 1x times secant squared of x. And this equation right here represents the slope of your original function. Next, let's go over how to use the quotient rule. To do the quotient rule, that's when you have a function divided by another function. So what you want to do is you're going to take the derivative of the first function first, and then again you're just going to multiply it to your denominator and you don't do anything to it. But in this case, this is different from the product rule because instead of a plus sign, it's now a minus sign. So the order here is very important. You cannot switch the order or you're going to get a negative of the answer that you should have gotten. So in the next piece, it will again be the derivative of the denominator times the numerator. But this adds also, you have to divide it by your denominator squared. Just like on the product rule, in some cases you can avoid using the product rule. So for example, if I have a function that looks like this, I can actually divide out each term if I have just a single term in the denominator. So I can go ahead and just separate each term a piece and then reduce it. And then I have, again, just simple power or constant rules. But if you wanted to use the quotient rule, you could. So let's go ahead and look at an example where you would have to use the quotient rule. In this case right here, I could not divide out the numerator because it's a binomial down here, not just a single term. You could try to bring this up and do a product rule, but that would also include a chain rule, which will be learned later. So I'm just going to leave it as a quotient. This is my first function, f of x, and this is my second function, g of x. So I just will follow the rule. So I take the derivative of the first function first, and the derivative of x is 1, and I just multiply it to the denominator. And then minus, now I just rewrite the first function, and I take the derivative of the bottom function, which again would be 1 plus 0, so it's 1 again. And that's all over your denominator squared. We are going to clean this up, but be very careful. Do not cross out the x plus 3's. They do not reduce. You want to simplify the numerator first. So if I distribute everything through, I will get x plus 3 minus x in the numerator. And the x's will cancel out. And that represents the slope of x over x plus 3. Let's do another example. What if I gave you a function of x squared plus 3x over cosine? Again, I have to use the quotient rule on here. There's no way to avoid it. I cannot divide out the numerator because nothing will reduce and nothing will combine. So I'm just going to leave it as a quotient. It'll make it easier. So what I do first is, again, I'm going to take the derivative of the top function first using power rules. So the derivative of x squared is 2x, and the derivative of 3x is 3. And then I just multiply it to the denominator of cosine. Then I put a minus sign, and then I rewrite the top function, and then I take the derivative of the bottom function, and the derivative of cosine is a negative sine of x. And then I put this all over cosine of x squared. Now there is a little bit of cleaning up you can do. Just make sure that you do not reduce these cosines. That is incorrect algebra. But this negative and this negative can combine to make it a positive. And you could distribute, but really nothing's going to combine or reduce. And so I'm just going to leave my answer like this. And then again, this represents the slope of this function. Thank you for watching Higher Math Solutions. See you next time.